Well, hello guys, I'm here Mr. G with another video for the grade 12. This time we're going to be doing another question of rate of reaction. We're going to be doing question 3 of the test for rate of reaction. And please, before continue, don't forget to subscribe so you can get all the notification and videos I post on regular basis. So let's get start with question 3. Let us use the reaction between impure powder, calcium carbonate, and excess hydrochloric acid to investigate reaction rate. The balance equation for the reaction is, and they give you the balance equation there. They perform 4 experiments under different conditions of concentration, mass, and temperature as shown in the table below. They use identical apparatus in the 4 experiments and measure the volume of gas produced in each experiment. And there are the 4 experiments and the conditions there. Define the term reaction rate in words. And then the reaction rate is the change in concentration of reactants or product per unit time. This is the answer. And the formula, if you may, it is equal to the change in concentration divided by the change in time. This is the reaction rate. The definition, there is the definition of that one. Question 3.2. The results of experiment 1 and 3 are compared in an investigation. Write down the independent variable. Results of experiment 1 and 3. Now, what they changed? The concentration was constant. The mass of impure calcium carbonate was constant. And what they changed was the temperature. So the temperature is going to be the independent variable. That one is temperature. Because temperature was changed by the person, the learners that were doing the experiment. What does depend on temperature there? The rate of the reaction. The rate of the reaction depends on the temperature. Okay, so temperature is independent because it was changed during the experiment, but the rate of reaction depends on temperature. Question 3.3 here. Question 3.3 is said, use the collision theory to explain why the reaction rate in experiment 4 will be higher than that of experiment 3. Now we are talking about experiment 4 and 3. So now is 4 and 3, those 2 experiments there. Now what they change there? The temperature stay constant now, but what they change is the mass of impure calcium carbonate. Note the following, that the calcium carbonate is impure, is not pure calcium carbonate. So that will have an influence here. Use the collision theory to explain that change in there. So for this question now, as it is impure calcium carbonate, when you add more calcium carbonate impure, there will be more surface area because in actual fact there will be more calcium carbonate now to collide with the other substance. So there, as you increase the amount of the calcium carbonate impure, you're increasing the surface area. So let's quickly answer 3.3 here on this side. 3.3. And the first point you'll have to say is that the surface area increases as you increase the amount of impure calcium carbonate. This one, of course, will increase the number of effective collision per unit time. Will increase the effective collision per unit time, and therefore there will be an increase in reaction rate. Therefore, the reaction rate increases. And guys, this one is question 3.3. Question important here. Learners obtain graph A, B, C, and D below for the result. And you have the different experiments A, B, C, and D. Which one of the graph A, B, C, and D represent experiment 1? Explain the answer by comparing experiment 1 with experiment 2, 3, and 4. Now, what is the problem here? A produces more volume of carbon dioxide. So for this question, guys, we have to compare experiment 1 with each of the experiments, okay? But we have to identify A. However, guys, to identify A, you note that all of the experiments have or release the same amount of gas right there. However, experiment A on the graph, you can see that release more gas than the others. Now, which one is the one that can release more mass? The one that has more mass of impure calcium carbonate. So, without doing any comparison, this one is experiment 4 will be A, because it will produce at the end more volume of carbon dioxide. So this one is experiment 4. That is the answer. However, now they want you to compare all of them, A, B, C, and D. So let's do that real fast. Okay, so for this question, we're going to use the table and we're going to use the graph. And we're going to start with experiment 1 and 2. So what happened with experiment 1 and 2? What is changed in here? Well, in experiment 1 and 2, the difference is the concentration. So all we have to do is going to compare. Alright, according to the concentration, experiment 1 was done under a higher concentration of hydrochloric acid, and therefore the rate of the reaction is going to be higher. So we have to say that experiment 1 has higher rate of reaction due to higher concentration. Note, higher rate of reaction than experiment 2. We are comparing experiment 1 with 2 right now. Is N2. Experiment 1 and 2. Therefore, experiment 1 will have a higher gradient than experiment 2. Therefore, the gradient in experiment 1 is greater than experiment 2 because it have a higher rate of reaction. So let's carry on. Let's compare 1 with 3 and 4. Okay? Now, in experiment 1, between 1 and 3. So let's now compare experiment 1 with 3. Let's remove this one here. Now in experiment 1 and 3, what is changed there? The concentration is the same, the mass of impure calcium carbonate is the same, the initial temperature of the acid is changed. So saying that, it means that now we're comparing experiment. Now this is experiment 1 and 3. Experiment 1 and 3. We can say that experiment 3 is faster due to higher temperature. Remember, we're comparing with experiment 1. And when you compare experiment 1 with 4, when you compare experiment 1 and 4, you can say that experiment 4 is faster due to the larger surface area. And to end, graph A, and this one is the end of the explanation. Graph A is going to be experiment 4. Why is experiment 4? We said it before, because it is not just because it's faster, but because it ends up with a higher volume of carbon dioxide. At the moment you have more mass in experiment 4, here you can see you will end up with a little bit more volume of carbon dioxide. So we can say that graph A is experiment 4 due to the greatest mass of calcium carbonate, and therefore it has greatest yield of carbon dioxide. From all this explanation, you can see here that the slowest one is going to be experiment 2 because it has a lower concentration, but then the temperature is also lower, so everything is the lower. So D is going to be experiment 2, telling us that C then is the answer for this question. C is experiment 1. That is the answer for the question, and B, obvious, is going to be experiment 3. Right, but the answer for the question is C. That one is experiment 1. You can see all the explanation here. You have to be comparing, and then eventually you will get to the fact of the gradients there, guys. So this one is the end of this question 3.4. Let's go to question 3.5. When the reaction in experiment 4 reach completion, the volume of gas formed is 4,5 cubic decimeter. Assume that the molar gas volume of at 40 degrees Celsius is equal to 25,7 decimeter cubic per mole. Calculate the mass of the impurities present in the calcium carbonate. Okay, guys, so let's see. This one is the question, this one is the reaction, and they are telling you that this one is in excess. So this time they are telling us that the acid is in excess. You have more than enough of this acid. They are also telling us that at the end of the reaction, the gas of carbon dioxide that formed this volume at the end of the reaction was equal to 4,5 cubic decimeter. That is the amount of gas released. And they are telling us also that the molar volume for this reaction at that specific temperature was 25,7 cubic decimeter per mole. That one is the molar volume. Let's write it here. Molar volume is equal to 25,7 decimeter per mole. Alright, so this is what they gave us, and they want to know what is the mass of impurities present in the carbon, the leftovers in actual fact, because all the calcium carbonate will react. So the first thing we have to do is to calculate the number of mole of carbon dioxide that is formed here, and we are going to use volume divided by molar volume. Remember, be careful, the molar volume we have to use is this one. All right, so we have that this 4,5 divided by 25,7. So the number of mole of carbon dioxide that we have here formed is going to be 0,175 mole. Now, from here, to form that amount of gas, we need to know how much calcium carbonate was actually reacting in here. So we're going to use the ratio between the calcium carbonate CaCO3 and the carbon dioxide. The ratio, guys, remember, are the numbers at the front, and therefore in this case is 1:1. So to produce 0,175 mole of carbon dioxide, you need how much? You need the same amount of mole here, which is 0,175 mole of calcium carbonate. Saying that if we calculate the mass of calcium carbonate that reacted by using this formula, guys, when we substitute here, we have that is 0,175 is equal to mass divided by the molar mass. When we do this calculation, we have that the mass of calcium carbonate that did react was 17,5 grams. But if we go to the question, we did use here the table, we did use 25 grams. So if out of 25, 17 reacted, how much is left? So the mass of calcium carbonate, which is impure, I'm going to leave it there, is equal to 25 minus 17,5, and then the mass impure is going to be equal to 7,5 grams. Answer: this is the mass of impure calcium carbonate. Well, guys, this one is the end of this question. It is a very good question. I hope it helped. If it did so, please subscribe for the channel so you can get more videos and notifications. Next time we're going to be answering question 4, so don't miss that video. Thank you for watching. Mr. G here.